All right, and welcome everybody to our in-depth fields and features segment where we cover sunspots, magnetohydrodynamics, and lots more, including solar flaring, coronal holes. First thing we're looking at are the last 4 hours of Earth's geospace, Earth's calm magnetic moment from about 12 Earth diameters. The scale depicted here is in nanopascals magnetohydrodynamic pressure, and things are quite calm here. Quite calm indeed, but not for long. We're expecting a major series of storms. So if you ever looked at the Space Weather Prediction Center, it's got a lot of links down here at the bottom. And one of the ones you may check out in the next 24 hours is the Aurora 30-minute forecast, as we are expecting geomagnetic storm conditions to arrive late today on March 30th and continue all through the day tomorrow on March 31st. It's going to be an exciting couple of days for space weather, as some coronal mass ejection strikes are expected to hit the Earth's magnetosphere. So next we're looking at ground magnetic perturbations, scaled in nanotesla. That's magnetic flux density, Earth's magnetic moment from the ground level. And as you may expect, things are also pretty calm here. As above, so below when it comes to the geospace magnetosphere movies and ground magnetic perturbations. For your new viewers out there, geospace delta B means changes to Earth's B field. Again, things calm at the moment. KP only at 1. We can expect to see this come all the way up to here, especially early in the day tomorrow. So there's a higher speed coronal hole, coronal mass ejection strike expected to happen late tonight, early into tomorrow. And then we can expect KP 4 through 6 throughout a large portion of the day. So a huge geomagnetic storm and geomagnetic unrest condition coming. Be prepared. There could be some power grid induction and so on, and we'll be covering it. Next, looking at the real-time solar wind here, we've seen a recent uptick in the solar wind density. Looks like another weak coronal hole high-speed stream coming here just before the coronal mass ejection strike. Again, we're expecting the coronal mass ejection strike late in the day today on March 30th and all throughout the day, as there are 2 significant coronal mass ejections headed toward Earth. They are incoming, folks. Current solar wind speed about 400 kilometers per second. Current solar wind density 6.26 protons per cubic centimeter. Here are your GOES magnetometers over the past 3 days. Those arc jet moments are when the spacecraft has to turn on its thrusters to maintain its geosynchronous near equatorial orbit. That creates plasma, which can affect the magnetometers. That's why they show it. Things pretty smooth there. Let's take a look at the heliospheric current sheet. There's a North Pole current sheet headed Earth's way. You can see that current sheet popping up here in green, right there where that arrow is. Keep in mind the magnetic environment can suddenly change with essentially no warning. Here's a line of sight view. Keep in mind this data is about an hour and a half old also here, folks. So there you can see the solar magnetogram. Lots of activity on the earthly zone. We've also got another coronal mass ejection, which we'll cover momentarily, so stay tuned for that. Next, the coronal hole line of sight plot showing the sun's B field in blue. You can see some South Pole-oriented coronal holes here just rotating into the earthly zone. As the solar polar field progression process happens, the south solar polar field migrating its way up to the north right in front of us, and the North Pole solar polar field migrating to the south. So it looks like additional North Pole coronal holes rotating in here. Right at the very end of the video, there's the last image. You can see some North Pole coronal holes there. So here's your 193 angstroms SDO imagery. This coronal hole right here is South Pole oriented. And the coronal mass ejections that are about to strike Earth came from this active region up here, Sunspot 2975, and the area around it. There are a lot of sunspots at the moment. We'll get to it. And here we are. So the likelihood of major solar flares continues, folks. Sunspot 2978 is beta gamma class, and huge Sunspot 2976 and 75 and 77 are all extremely significant sunspots. Even Sunspot 2974 down here spent some time as Beta Gamma class. Make sure you tune into our bonus features segment, as we will have close-ups in high res of the current state of affairs. They've largely stayed stable here over the past 24 hours. And here's a full disk view. 1700 angstroms is extreme ultraviolet light. You can't see it from the ground, folks. You can only see it from space. And the spacecraft seeing it is the SDO, the Solar Dynamics Observatory. We'll continue on with some close-ups of these major active regions. First, I'd invite you to press like and subscribe. Tell your friends and foes about us. Press the share button. If you haven't checked us out on BitChute, we've been putting up exclusive content on there for the better part of a week here. Expect that to continue. Also, we regularly stream live to Twitch. We've already got a video up there live if you haven't seen that. Visit our links. You can find links below the video as well as on our homepage at smashomash.com. Smashomash.com. Welcome to the Neo-Renaissance. We are indeed in the process of writing a paper explaining the mechanism underlying the solar polar field and solar sunspot cycles. If you want to support the content, consider becoming a member of the Smash team at smashomash.com/Smash team. Again, links at the homepage and below the video. Additional content for gold and silver level. So help us out by throwing us a few dollars per month to help the content continue to exist and remain publicly visible for all to view. Next, we'll view the Sunspot 2978 and surrounding region here. Looks like the area to the south of it may have degraded a little bit here. Again, likelihood of solar flare still very high. So that's Sunspot 2978. Here it is in 171 angstroms. That is a house favorite wavelength. There is still a huge filament out here. You can see this huge plasma filament right here. It looks like an absorption feature. A chemically rich area. Those white areas are very high in a specific species of iron. That portion of the ultraviolet spectrum is 171 angstroms. And we'll slow this way down. And switch to 94 angstroms. So here's that area. Again, this area right here, Sunspot 2978. And whatever that group to its south is called, here it is in 94 angstroms at 1/3 speed. So we've slowed this down because it's got more imagery. Great view, 94 angstroms is also part of the ultraviolet spectrum and another one of the many ionized species of iron. Iron nuclei want a lot of electrons, and at different levels of heat and so on, they've got a different number of electrons. That's what we're looking at here. I don't memorize how many electrons that species of iron has, but there's the imagery from the SDO. One of the best wavelengths to view solar flares. Continuing on to these northern regions, Sunspot 2975 and the surrounding sunspot groups. Also quite capable of producing major flares. You can see some flaring there. There's all kinds of M and C class flaring happening. The sun is basically at least the Earth-facing side is basically at a background mid-sea level flare profile now. It's not even really flaring, it's just background putting out lots of X-rays. And you can see a light bridge forming across the umbra here of Sunspot 2975, perhaps showing some degradation of that sunspot. Here's the same zoom at 171 angstroms once again. Spectacular imagery. And here's a slowdown. This is 1/3 speed, 10 frames per second instead of 30, which is what we were showing. You can see all kinds of activity and all sorts of filamentary structures, perhaps forming and collapsing, but certainly giving you insight into electron flux in those areas. So super exciting times for space weather. We've got our fingers crossed that we may see Aurora all the way down here in Lehigh Valley, Pennsylvania. AccuWeather doesn't seem to think so, but it is possible. It all depends on things like magnetic field orientation. Don't worry, folks. The sun's not going to kill you. If civilization collapses, mankind might kill you, but the sun is not going to kill you. Maybe if you get an extreme radiation dosage by being in deep space. Otherwise, just stay inside the magnetosphere. You'll be just fine. Next, there goes X-ray flux here over the past 3 days, and you can see we've got like just a background level of C-class X-ray output without what you'd even call flares. It's just a significant uptick here in solar activity. So here you can see the 7-day chart. Huge couple of days of activity there, complete with Earth-directed coronal mass ejections. We covered it very quickly. Proton flux, you can see it's slowly subsiding here. The polar radial blackouts have largely subsided. They were a little bit shorter than we expected. We did forecast high-frequency radio blackouts around the poles. Those particles showed up in only about 20 minutes, traveling at about 30% the speed of light. Next, chart of the solar system here. And keep in mind, this is not to scale. Let's advance this 1 week. There's where things will be in a week. We'll have a crescent waxing. And I just wanted to bring up the apod.nasa.gov. apod.nasa.gov, the astronomy picture of the day, showing moon phases. So this is a great little video here. I'm only going to play a little brief portion of it. The last few days. And the next few days. So the good news is if you have clear skies, folks, you're going to have near new moon conditions. The best scenario for watching Aurora. If you think you're seeing Aurora, make sure you take video of it, as the ultraviolet spectrum is included there, and there may be imagery up there that you can't see with the naked eye. Your phone will be able to pick up some stuff you can't see. So if you think you're seeing the Aurora, make sure you take video of it, or at least photographs, as it occupies the ultraviolet portion of the spectrum. Some portions of it occupy the ultraviolet portion of the spectrum, which may or may not be visible. Probably not visible if it's ultraviolet light. Anyway, you get the idea. Use your phone, take a video. Next, a star chart. If you're up before dawn, you may see Mars, Saturn, and Venus hanging out close to the ecliptic there. It's a planetary pileup. And we'll close things out with the coronagraphs. We've got another coronal mass ejection. Don't worry, folks, this one is not earthly directed. So from stereo A's perspective, Earth would be off in this direction, and you can see this coronal mass ejection on the far side of the sun. It may look like a halo on the LASCO C3, which is a characteristic of an Earth-directed coronal mass ejection, but that one's not. It's on the far side of the sun, a perfect example of how deceptive it can be. So stereo A is located out here, putting Earth off to your right. The SOHO LASCO C3 is at Lagrange 1 here, putting Earth behind you. Again, not an Earth-directed coronal mass ejection, but two are indeed on the way. Thanks for tuning in to the Daily Space Weather, where we cover things in depth. We don't fearmonger. We don't misrepresent science papers. We just present you with facts and some accurate forecasts about all kinds of solar activity. Turns out, folks, when you immerse yourself in the data, you may get results you were not expecting, as sometimes the rabbit hole of science provides us answers to questions not even asked. So in any case, thanks for tuning in. May that solar wind be at your back. We'll talk to you soon at the Smash News Network, least busted name in news.